Hey guys, welcome back. Today's lesson is about roots. In particular, we're going to talk about two types of roots. We're going to talk about square roots, which I believe my 8th grader said they were familiar with from last year, and cube roots, which maybe you aren't as familiar with. So, a quick little intro. A square root is usually represented with this symbol. This is called the radical symbol. This is called a radical. It just wants you to do the positive or the principal square root. That's also what it's called. But anyway, this is what questions usually look like. And whenever you do a square root, what you're asking yourself is what number squared, what number times itself equals the number inside the radical symbol called the radicand, I believe. So, and on this one, what number times itself equals 25? Most people would know that that has to be 5, right? 5 times 5 equals 25. For 100, what number times itself equals 100? What number squared, what number to the second power equals 100? That would have to be 10. Notice, this is not like 25 times 4 or 20 times 5. No. 50 times 2. It can't be that way. It has to be the same number multiplied times itself. That's the whole point of a square root. It's what number squared, what number times itself equals 100. It has to be the exact same number, like 1 times 1, 2 times 2, 3 times 3, all the way up to 10 times 10, or even higher. What we're also going to learn, which I don't know if you saw last year, is a cube root. And a cube root is very similar to a square root. A cube root is going to look like this. It's going to look the same, except it's going to have this little 3 by it. And so I'm just going to pick an easy one. This is a kind of an easy one. This one isn't too hard. It's not that easy, though. It's going to look like this. And so if you see a question like this, it's asking you basically what number times itself 3 times is 64. It has to be the same number times itself. So don't tell me it's like 8 times 8 times 1. No. It's got to be the exact same number. And so if you don't know, what you might have to do is just try. Is it 1 times 1 times 1? No, that equals 1. Is it 2 times 2 times 2? And take a calculator if you need to, or work it out in your head. That's 4. 4 times 2 is 8. Nope. Is it 3 times 3 times 3? Let's see. 3 times 3 is 9. 9 times 3 is 27. No. Is it 4 times 4 times 4? 4 times 4 is 16. 16 times 4. It is 4 times 4 times 4. So the answer to this one, 4 times 4 times 4, the answer to this question would be 4. Okay, do you see how I did that, though? I just started with the smallest number and worked my way up. Now, I'll be honest with you, the state of Missouri is going to ask you questions like this eventually, and they will do it on the part of the map test where you have no calculator. They expect you to know all the way from 1 times 1 times 1 all the way up to 10 times 10 times 10. That's as high as they expect you to get because that's 1,000. So that's something we'll work on as the year goes on, but we don't have to be experts right now. Here are what some square roots look like. We'll start easy. What number times itself equals 64? There is a square root button on your calculator, but let's be honest, most of us know 8 times 8 equals 64, and so our answer to this one is 8. Okay, they're going to start messing with you and putting stuff out here in front of the radical sign. That is okay. Let them put whatever they want out in front of the symbol. If it's out in front, it is completely legal. Like, for example, this one, it has a plus and then a minus. If you've never seen this before, this just means positive and negative. I know the answer is 5, right? Because 5 times 5 is 25. If they put stuff out here in the front, just copy it down. It's okay. It's part of your answer. So this answer is really 5 and negative 5. You have 2 answers on this one, 5 and negative 5. If it's just a negative sign, can you have just a negative sign out here? Yeah, that's fine. Do this first. It's almost like this is in parentheses. You have to do that first. What's the square root of 81? I believe that's 9, right? 9 times 9 is 81. If they have something out in front, that's cool. Just copy it down, and then that's it. Negative 9. Negative 9 is our answer. Now, here's where it is not cool. If they put a negative inside of the radical sign, do you see how this one is inside the square root, and this is on the outside? That is a big difference. If it's outside, it is okay. You can put it on the answer. If it's inside, you cannot do this question. There's no number that if you multiply it by itself will ever equal a negative. Because remember, if you multiply something by itself, the signs are the same. And if the signs are the same, the answer has to be positive, right? 4 times 4 is positive 16. Even negative 4 times negative 4. When the signs are the same, the answer is positive. There's no way to get negative 16 by multiplying the same thing times itself. The only way to get negative 16 is to do this, which is technically not to do positive 4 times negative 4. But is that the definition of square roots? No. Is that the same number times itself? No. These are opposites. Those are not even the same number. So that is illegal when we're talking about square roots. There's no combination. So you can say this, which means no solution, or if you want to write it, you could put no real solution or no solution. If they ever put a negative inside of a square root, this is only for square roots, negatives inside of square root symbols are illegal, and you say no solution. Okay, I'm going to go a little bit quicker here for the rest. If they give you fractions, don't let that bother you. Just treat it like 2 smaller problems, right? Instead of 1 big scary looking square root, do 2 tiny ones that are easy for you. Would everyone feel comfortable doing the square root of 49? What number times itself equals 49? Of course, we all know that's 7. Would we all be able to do the square root of 84 and say, okay, I know 8 times 8 is 64? Sure. And so just make that your process. When they give you a fraction, just do the numerator all by itself, and then do the denominator all by itself, and then just make it a fraction. Reduce it if you can, but this one's already reduced. This one, once again, I've got a plus and a minus out at the front. If it's in front of the symbol, in front of the radical, it is completely legal. You can have positive and negative, and then just ask yourself, what number times itself equals 144? I think that's 12, right? That's kind of a hard one, but a lot of 8th graders know that one. Here's another one. It's a negative. Is that legal? Yes, because it's in front of the symbol. That is okay. It's almost like saying the opposite of the square root of 9, right? You can almost read that as the opposite of the square root of 9. The square root of 9 is 3, and then the opposite, or the negative, just means negative 3. Here's where it's illegal, right? This is no good. The negative inside of the radical, inside of the square root, this is no good. This is not possible. This is no solution. Sorry about that, interrupting on the intercom. Okay, one more. What about if they don't give you a radical symbol? See how all these had the symbol? Symbol, 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 symbol. What if they give you an equation? What number squared equals 100? It's the same idea, right? This is the same thing. What number squared equals 100? That's obviously 10. Oh, but is it also negative 10, right? Does 10 times 10 equal 100? Of course it does. Does negative 10 times negative 10 also equal positive 100? Actually it does, right? Because when the signs are the same, the answer is positive. So when they give you an equation, you're always, always, always going to have 2 answers. Like this one had positive and negative. When there's an equation, you have 2 answers, 10 and negative 10. You can write it like this. If you want to do the little plus and minus thing like they did on that other one, you can do that as well. But that's a big difference. When they give you a radical sign, it's usually just the positive, or here it's just the negative, or here it's both. But when they give you an equal sign with a variable, A, T, W, whatever, you will guaranteed have 2 answers when it's a square root. And I'm sorry, this is fading. So on this one, what's the square root? What number here is going to equal 16? What number squared equals 16? That's got to be 4 and negative 4. When it's an equation, you have 2 answers. And here, square root of 9 over 25. If I don't know that in my head, what's the square root of 9? What's the square root of 25? That's 3 times 3 is 9. 5 times 5 is 25. So we have positive 3 over 5 and negative 3 over 5. Do you see the big difference? When you see an equal sign and you see a variable, a letter, right? W, A, T, whatever letter you want, you know you're going to have 2 answers if it is a square root. Square root. Okay, that wraps up square roots. You were probably like, dude, that was easy. I didn't need to watch all those. Sorry. What about cube roots? Cube roots, now you might need a little bit of a cheat sheet, right? I had an awesome student one year who just made a little cheat sheet for herself, and she just did this. She did 1 times 1 times 1. She did 2 times 2 times 2. She did 3 times 3 times 3. Because, let's be real, would I love to use a calculator for this? Of course. But will the state of Missouri always let me use a calculator for these? No. And so I need to be prepared if they give me no calculator. I'm going to switch to a different color just because my orange one gets a little bit thick. 7 times 7 times 7. Oh, geez. If you don't know it, don't be scared to actually do, okay, 49 times 7. I think it's 343. Yeah, 28 plus 6. That's what I thought. I just wanted to make sure. And this is what you might have to do. you might have to do 8 times 8 times 8. Okay, that's 64. 8 times 8 is 64. 64 times 8. It's okay to do this if you have to, right? Don't feel embarrassed. I'm the teacher of the class. I've been doing this for a long time. And sometimes I even need to do this. That's 81. 81 times 9 is 729. And then 10 times 10 times 10. So even though you don't get a calculator, would everyone be smart enough to do this off to the side on their own? I hope so, right? And now we have our little cheat sheet. No matter which question they give me, I'm going to know the answer. For example, look at this one. What's the cube root of 27? What number times itself 3 times equals 27? Look, it's right here. 3 times 3 times 3 equals 27. So my answer to this one is 3. Right here. The cube root of, earlier I said you cannot have negatives inside of the symbol. And earlier we said that meant no solution, right? If I go way back here, see how on this one I said a negative on the inside means no solution? That is only for square roots. Can I have a number times itself 3 times that equals a negative? Like, look, here's 64. It's right here. Could this one be negative 4? Sure, it could, right? You can have negatives on the inside if it's a cube root. Negatives on the inside of the radical symbol are okay if this is cube root. If it was square root, it would not work. Because look, negative 4 times negative 4, that's positive 16. Does positive 16 times negative 4, the signs are different? So the answer is negative. Look, it does work. See, it does equal negative 64. So the answer to this one is possible. Negatives are okay when it is a cube root. Negative 4 is good. And here, the cube root of 1,000, that's the biggest one you would ever need to know. Look, it's right there, 10 times 10 times 10. The state of Missouri says 8th graders need to know all the way up to 10 times 10 times 10 on their own. Whether you have it memorized, great. Do I even have these memorized? No. But could I definitely make this little chart for myself? Of course I could. Okay, I'm going to do another one. I'm going to keep my chart up to the top here where I can see it. You can't see it, but I can see it. The cube root of 216. Okay, I don't know that. I'm going to look at my table. The cube root of 216 is right here. 6 times 6 times 6. So this one is 6, right? It's 6 times 6 times 6 equals 216. The next one, the cube root of negative 125. Is it okay to have a negative inside if it's a cube root? Yes, it's okay. So I'm going to look at my chart for 125. On my little chart, 125 is right here. 5 times 5 times 5. So this is actually, since it has that negative, I'm going to make it negative 5, right? Negative 5 times negative 5 times negative 5. Whoa, that's an ugly looking 5. Would be negative 125, right? Because these two, if you multiply these two, you get positive 25. And then positive 25 times negative 5 would equal negative 125. Okay, and then this one, it got shoved underneath my other board and now the marker's fading. The cube root of 8 over 27, you can still do that. Just do it, split it up, right? Do the numerator on top, do the denominator on the bottom. Do I know the cube root of 8? Of course I do. It's right here on my little table. Right here, 2 times 2 times 2. So the numerator to my answer is 2. The cube root of 27, look, it's right here. 3 times 3 times 3. Whoops, kind of marked on it there. So that one is 2 over 3. Okay. Cube roots. Make a little cheat sheet for yourself, or just pause this video right here, and I've got it for you. Make your little cheat sheet, or pause this video. Cube roots, you can do negatives. Negatives can be in the front, negatives can be at the end, negatives can be inside the cube root, inside the radical. Negatives are okay. Okay, the last ones, if they're trying to be rude to you, they will give you an equation. Don't let that bother you. We can still do it. This is the same thing as this. What is the cube root of 216? I just had it on my last one. If you didn't remember it, it's right here. 6 times 6 times 6. Okay, do I need to put positive and negative on this one? No, you do not. Cube roots only have one answer. Because negative 6 times negative 6 times negative 6, I don't want to put negative on this one because that would actually equal negative 216. Okay? So this does not have the negative version. It's only the square roots that might have two answers. What cube root would equal negative 343? I don't know. Let me look at my chart here. Here's 343, 7 times 7 times 7. And so since this has a negative in front, this is just going to be c equals -7, right? -7 times -7 times -7. And then the last one, cube root of 7, what number to the third power equals 729? I've got it right here, 9 times 9 times 9. And this is where a calculator can help you. You can just type in your, type in your calculator if you have one, 9 times 9 times 9, and you'll eventually get it. And there it is. Okay, guys, so I'm going to stop because I'm almost at I'm a little over 15 minutes. This is cube roots and square roots. Quick little recap. Cube roots. If there's an equation with an equal sign and a letter C or a W or a whatever, there's only going to be one answer. One answer. One answer. Over here, one answer. One answer. One answer. The only time you could ever get two answers is if they ever put a plus and a minus way out at the front. And I don't even think they would never do that because actually, you know what? Well, I don't think they'll do that to you. They might, but I doubt it. Square roots are a little more specific. Square roots, a negative inside the radical is not possible, only on square roots. See, there's no number 3 right here. And also on square roots, if they give you an equation with a T, an A, a W, a C, if they give you an equation, you will always have two answers, 10 and -10, 4 and -4, 3/5 and -3/5. It only works like this on square roots, not on cube roots. Okay, so thank you so much for watching this video, guys. I hope this helps you understand cube roots and square roots. Also, a quick shout out to the Bayer company, B-A-Y-E-R. They provided this nice little phone stand so I don't have to hold my phone and I can record this video. They provided it for the school, and so a shout out to them. Thank them very, very much. And I want to say thanks for watching this video. Go on our McGraw-Hill math website, and I will have some questions for you about this. Feel free to watch this video, pause it, rewind it, watch it as many times as you want if you need help, and also send me an email or leave some comments in this video if you want more explanation on anything. All right, thank you so much for watching, guys. I'll catch you in the next one.